Alright, so let's take a look at writing the equation of an ellipse. So we're only going to look at ellipses that are centered at 0, 0. So that means that the intersection of your major and minor axes are at the point 0, 0. So the general form of the equation of an ellipse is going to be one of these two things. And really the only difference is where your the length of your major axis is and where the length of your minor axis is. So if it's stretched more in the x direction, so the a and b are really the amount of stretch in either direction. So if x is stretched, if it's stretched longer in the x direction, then it'll be like this horizontal ellipse here, and the equation will look like this. And if it's stretched more in the y direction, then it'll be a vertical ellipse, and it'll look like this. And then just a recap of the fact from the end of the video, we talked about the fact that c squared plus b squared equals a squared, which will actually lead us to this, which is what we're going to use it in this form instead. So let's take a look at the first example. So for the first example, you're asked to write the equation of ellipse, and you're with the given foci, and the sum of the focal radii is 10. So the sum of the focal radii is just saying that this right here is a focal radii, and so is this one. So they're sort of like the radius from the focus, and there are two of them. So the sum of the focal radii is just saying that the sum of these two segments is always going to be equal to 10. So no matter where I pick a point, if I pick a point down here, this distance plus this distance will always be 10. And as mentioned in the previous video as well, we know that that set distance is always equal to, so that set distance that defines the ellipse is always equal to 2a. So here's just an explanation of why that set distance is going to actually be equal to 2a. So here's an ellipse centered at the origin, and I've just labeled the foci as c, 0 and negative c, 0. So these are always the same distance. So if we went out 5 units in this direction, we'd also go 5 units backwards. So whatever c is, it's going to be the negative value out here and the positive value here. So if I pick this point on the ellipse, I'll call that point a, 0. So I know that by definition, the sum of the distance is constant. So I know that this distance plus this distance right here is going to be that set distance that's going to define our ellipse. So this distance right here is a minus c, right? So if I went all the way out here, if a were 10 and this were 7, that distance would be 3. We would get it from doing 10 minus 7 would get us that distance. And then the distance from this point to the other focus is going to be, this is c, and this is a, so that whole distance is going to be a plus c. So that means that our set distance that defines our ellipse is going to be this plus this, and then the c's cancel, and we just get 2a. So that's our constant sum of our distances. So that's just a quick explanation as to why that is 2a. Alright, so what that means then is if my set distance, in other words, that set distance is the sum of my focal radii. So what that means is that 10 is equal to 2a. So then we get a equals 5. So we're halfway there, right? Because if we're going to write the equation of our ellipse, first of all, we know this one's going to be horizontal, by the way, because if my foci are at these points, that means my major axis goes this way, because my major axis always has to go through the foci. So halfway there, I know what A is. Now I need to figure out what B is. So now we're going to use this fact right here. So I know that c squared is equal to a squared minus b squared. Well, I know what A is, right? I know that A is 5, so I can already substitute in here 5 squared. And then C is just this distance from the origin to the focus, which we know is 3. So now I can do 3 squared equals 5 squared minus b squared. So if you go ahead and solve here, we get 9, 25. So we're going to get b squared equals 25 minus 9. So b squared is going to be 16. So b is going to be 4. And actually, what we really need is this. So I don't actually really care for, if I'm writing the equation, I don't actually care what b is. What I care about is what b squared is. So when I'm plugging in here, I need to know what a squared is and what b squared is. So that means that the equation for this ellipse is going to be x squared over a squared, which is 25, plus y squared over b squared, which is 16, equals 1. So that would be the equation of the ellipse that satisfies those conditions. Alright, so let's take a look at another example where you're given an equation of an ellipse, but it's in non-standard form. So remember, the standard form for the equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. And we might have to swap the a and the b. Alright, so we need to get this into this form. So we need to get it so that it's equal to 1. So we're going to do that by just dividing both sides by 144. So we're going to get 9x squared over 144 plus 16y squared over 144 equals 1. And now on the left side you can actually reduce some things here. 9 over 144 is actually 1 over 16. So this divides, and that will be 16. And this is actually then going to be 9. So we get x squared over 16 plus y squared over 9 equals 1. So we did end up at this form, right? The a squared, the larger number, ended up being under x. So which form it is doesn't actually matter so much as just that you recognize that the larger value here is going to be a. So we know that a squared equals 16, b squared equals 9, and now if our goal here was to find the foci, we know that it's centered at the origin because we can be written in this form. So what we need here, and we know that it's stretched more in the x direction, so we know that our foci are going to be here and here. So we know the y-coordinate of our foci are both 0. So what we need to figure out is what c is, and that's where we're going to use this fact. So I know that c squared then is going to be 16 minus 9, right? So it's a squared minus b squared. So c squared is going to be 7, which means c is plus or minus the square root of 7. So what that means is that the coordinates of this point are going to be negative square root of 7, 0. And the coordinates of that point are going to be positive square root of 7, comma, 0. Alright, so let's take a look at another one of those. So same idea here, right? We want this to be in this form, so we need this to be a 1. So we're going to go ahead down here and divide everything by 75 on both sides. So over here we're going to get 1, and on the left side, 5 over 75 reduces to 15, and 3 over 75, we'll get a 25 in the bottom. So that means now that our a squared is 25, our b squared is 15. And because there's more stretch in the y direction, our ellipse is going to look like this. So that means our foci are going to be along the y-axis. So that means here our x-coordinate is going to be 0, and our y-coordinate we're going to have to solve for using this right here. So I know then that c squared is going to be 25 minus 15, so c is going to be plus or minus square root of 10. So that means that this coordinate up here, that's going to be the positive. So our x-coordinate is 0 and our y-coordinate is positive root 10. And down here, our x-coordinate is 0 again, and our y-coordinate is going to be negative square root of 10. So our foci here would be these 2 points. So there's a couple of examples. Hopefully that'll be enough to get you going.